Off we go.
Right. Yes! The last question of our mammoth afternoon. The matrix X is given by that. A292831 minus 1. Find the determinant of X in terms of A. Right. So, you remember, you can pick any row or column that you like to work this out. I think I'm going to play it safe and just do the top row because that's the one that we normally do. But on occasion like this, you know, doing it from the bottom row, that has certain appeals, doesn't it? Because you're not multiplying by anything as you go through. Oh, you know, 1 and minus 1 and that nice little 0 in the middle. Maybe that would save us a little bit of time. Shall we do it with the bottom row? Okay, so you can remember you can choose any one you want. The bottom row is going to be 1 times that minor determinant there, 29A3, and then it's going to be 0 times that bit. I'll for completeness I'm going to write it. It'll be minus 0. Not that that matters. A3. What is it? A923. And then you'd have plus minus 1 times A2 to A. And if I were doing this, maybe I wouldn't have written that line out. Maybe I would have gone straight to saying this is going to be 6 minus 9A. We've got 0 in the middle, because all that's going to disappear. And we've got minus A squared minus 4. That's that bit up there. And so I have got, well, we've got 6 minus 4, 10, minus 9A, minus A squared, and that's my determinant. Okay? You would have got the same choosing any row or any column to work it out with, as long as you remember to adjust the signs according to that pattern there. And it's important to remember that. Great. Ooh, 3 marks, just like that. Hence, find the values of A for which X is singular. Well, we've learned this, haven't we? We remembered that if a matrix is singular, then its determinant equals 0. So really, again, this is a little bit of core 2, really, isn't it? It's just saying, find the values of A for which 10 minus 9A minus A squared equals 0. Depends how confident you are with this. I might like to rewrite this like that first. A squared plus 9A minus 10 is 0. And factorise it. 10 and 1. A plus 10. A minus 1. So A equals negative 10. And A equals 1 are our 2 values of A for which it is singular. Brilliant. Another quick 3 marks. That's great, isn't it? Given that X is non-singular, find the inverse of X in terms of A. Not really that difficult, it's just a big hassle, isn't it? So, part 3. I can't see the matrix anymore, so I'm just going to write it again so that I've got it. A 2, 9, 2A3, 1, 0, minus 1. We remember all the steps that we have for this. I don't know how exactly you've learned how to do this, in what order you've learned to do it, or what steps, but I'm going to work it through in the way that I would normally do this. So I'm going to start by doing my new matrix of minor determinants. I'm probably just going to work these out straight away. I'm not going to write the huge detail. One thing that I know when we did an exam at one point, my class, a few people did wrong, was when working out the minor determinants, they multiplied by the value there, but remember we don't do that. So this first minor determinant is what we get if we work out that determinant. So minus A plus 0 times 3. So that's just minus A. The next one, remember you can do that again if you want to, is that, those four, so that's minus 2, take away 3, minus 5. The next one is 2 times 0 minus 1 times a. So that's a minus a as well. Next row, so we're row 1, column, row 2, column 1. That's 2 times minus 1, because 0 times 9, take away 0 times 9. I bet you wish you had a pen that just faded away in the exam so you could do it. It makes it easy, doesn't it? Minus a, minus 9. And 0 minus 2. Are we okay? Are we all happy with this? Is this, you remember how to do all of these? Then the bottom row, well, we've kind of already worked some of these out, haven't we? That is 6 minus 9a. We've then got, fading out fast enough, 3a minus 18. I'm running out of space. And a squared minus 4. Sorry, that's really small, but are we okay with that? Right, so that was the minor determinants. What should I do next? I will transpose this matrix. So, I've calculated my minor determinants. I'm going to transpose it, which just means that every row becomes the corresponding column. So the first row becomes the first column. The second row becomes the second column, and the third row becomes the third column. So it looks like that. I've done my minor determinants. I've transposed. I need to adjust my signs according to that pattern that we wrote at the top of the page. So it goes plus, minus, plus, minus, that one's plus, that one's negative, so I'm going to write 18 minus 3a. That one is plus, that's negative, and that one remains positive. There we go. And my very final step is to remember to divide it by the determinant that I found earlier. So, x to the minus 1 is 1 over, and my determinant was, now let's get this right, it was way up here, 10 minus 9a minus a squared. Making sure we don't do the, we made it negative before we factorised it, so don't get misled by that. It's going to be that original version, and then we've got minus a to 6 minus 9a, 5, minus a minus 9, 18 minus 3a, minus a to a squared minus 4. I did quite a few steps there. We could have merged some of those steps together. You maybe could have done the signs and the transpose at the same time, or you maybe could have done, lots of it at the same time.
Yes, it doesn't not matter where you do the signs, but it's a sign.
It doesn't matter at what point you do the signs or the transpose, because this little pattern of signs, it's the same even if it's transposed, isn't it? So it doesn't make any difference what order you do those things. Okay. And even if you do them together, and in fact divided by the determinant as well, it doesn't matter at what stage you do that. It's really important to remember you don't need to bring that inside, because that would create quite a mess, wouldn't it, if you divided every single term by all of this down here. So there's no need to do that. It's all right to leave it as a fraction in front. And that's maths.
Way.
Oh, James. Yeah.